We're proud to announce that Isovalent Networking for Kubernetes is now officially supported for hosted control plane. This milestone makes us the first and only CNI currently to achieve the brand new hosted control plane certification and strengthens our position as the enterprise choice for secure and scalable Kubernetes networking. Just as a little debrief at the start, what actually is hosted control plane if you're using Red Hat OpenShift today but haven't looked at maybe some of these deployment options? So hosted control plane is a modern cloud native architecture that allows the control plane components of an OpenShift cluster. So think about all those services that run inside of those control plane nodes when you deploy your cluster, such as the API server, the control manager, TCD, and scheduler. They're decoupled from nodes and they're run as pods on a separate management cluster itself, allowing you to just deploy new clusters. So think about like kind of tenancy type deployments whereby you just have worker nodes. These components are not tied to dedicated virtual machines, physical servers for each cluster, but instead running on that existing management cluster. What does that look like from an architectural point of view? So in this diagram here on the left hand side, we've got that typical standalone control plane deployment model that we all know and love and have used with OpenShift over many years. You would see that control plane with the control nodes deployed with all those components. You'd have that work pool, which have the worker nodes as well. And then on the right hand side of the diagram, we've got this new architecture, which is the hosted control plane architecture. It's supported by a project called Hypershift under the hood. And essentially you have a cluster which is servicing all of the control plane services itself for each individual cluster that it's attached to as well. So we can see here we've got a cluster 1 namespace, a cluster 2 namespace, and that replicates having the API server and other control components deployed into those namespaces. And then outside of that cluster itself, that's the management cluster that sits in the middle, we've got the worker kind of clusters deployed outside of that, where it's just those nodes and it's just focused in running your actual workloads itself. There's a number of architectural benefits that come with that, such as cost efficiency, faster provisioning, improved isolation. Think about those tenancy type environments as well, simplified operations as well as you kind of hand off these clusters to your different teams. So before I dive into the live demo showing you this working with Isovalent Networking for Kubernetes using Cilium under the hood there, I just wanted to show you the official certified OpenShift CNI plugins page. I'm just going to do a quick Control F. We're going to look for HPC, which is the abridged version of hosted control plane. And as you can see, we only get one match down here, and that is for our offering, and we're certified across 4.16, 4.18, 4.19, and we're the only CNI that offers this today. Now I'm going to take you through deploying a new cluster on top of our existing hosted control plane management cluster that's already running Cilium. Show you those commands, show you some of the little kind of configuration options that you need to have in place to do that. So first and foremost, we have our default OpenShift cluster deployed in AWS today. The host control plane, if it meets the requirements in the deploy cluster, will be enabled by default. You can disable that. Just read the OpenShift documentation. Do always recommend you go through that for the prerequisites and so forth first anyway, to get a good understanding of how the architecture works and what's expected before you kind of dive into these things. I'm going to double check the status of that. So the multi-cluster engine is already up and available, and the Hypershift add-on. So Hypershift is the project behind this host control plane capability inside of OpenShift. So that add-on is deployed, is available, and is healthy. What does my OpenShift environment look like already? It just looks like any other deployment into AWS, all of the normal namespaces, pods that you'd expect to see for a brand new cluster. And obviously if I go very to the top here, because we've already installed Cilium into this cluster, because it works the same way as when we install Cilium into any OpenShift cluster, we've got all of our pods deployed already inside of that. And then if I clear down, I'm going to do just a quick status to make sure that Cilium's healthy, which it is, which is fantastic. And again, this Cilium runs its own Cilium config here that's stored locally. So just to show you a quick little bit of an output for that as well. So we'll clear that down. So basically this is a normal OpenShift cluster, but has the prerequisites in place so that it's automatically deployed the host control plane options today. Now we're going to create a new cluster that we're going to install Cilium on. However, unlike a normal OpenShift deployment, if you remember from the architectural diagram, the control plane nodes don't exist. The services that run on a control plane node will actually run inside of my management cluster in its own dedicated namespace itself. So let's run a command for this. So there is a special HCP CLI tool that you can download. We've obviously created this in AWS. We provided a number of details in place, and it's going to go off and do that for me. Okay, so that took probably 2 minutes to create. We obviously speak through things like that on the video. So now I'm going to see the status of that cluster that's being created. So it has its own cluster resource definition inside of my OpenShift cluster. So we're still connected at the moment to that management cluster. So we can see now it's partial, it's unavailable, the control plane is not held. So we've been about 10 minutes or so now for my cluster to get up and running. So now what we can see is that we have our cluster, we've got a kube config available, it's partially available, so it's partially in progress, but available is true, which means the host control plane side of things is available. But of course, we haven't installed Cilium here, because if you remember earlier, when I created this cluster, one of the things that I wanted to call out is we set the network type to other, which basically means don't install a CNI. That then means there needs to be an additional steps, whether it's manual, like I'm doing today in this video, or whether you build this into your GitOps methodology and deployment services to then connect to the new cluster once it's available so that you can then set up and deploy and configure the CNI to bring this cluster fully up and readily available. So now I'm going to run a command to see all of the pods that run that should be pertinent to running a standalone cluster. From a management perspective, you'll see that we've got a new namespace. So it's prefixed with clusters hyphen, and it's going to be the name of my cluster. Now, if I look at the pods that are running there, this is going to be everything that would run as we'd expect on the control plane nodes in a standalone cluster. But because we're on the management cluster inside a host control plane, this is centralized. So I think now it makes sense for us to move over, connect to this new cluster we've created and get Cilium installed on it. So I'm going to clear down my terminal. We're going to use HCP command again to create a kube-config file for me so that I can connect. I'm going to export this to my variable. And now if I do get nodes, we can see I connected and I got 3 nodes available and they only showing the roles of worker because again, no control plane nodes. That's the big point I keep reiterating here for hosted control plane. And as you can see, the status is not ready because we have no CNI. But I'm going to have a quick look at the pods that are running as well. As you can see, this is kind of a shorter list than what we'd expect when we have a full OpenShift deployment to standalone cluster. We've still got some management deployment services there, things like CSI that are going to be needed, things like DNS, image registries. We've got kube-proxy deployed at the moment, so I'm going to show you a key config for that as well. So I guess we need a little bit of information before we get started. So I'm going to create 2 variables which get my Kubernetes service host address and my Kubernetes service port. So I've just got 2 commands wrote up for that. And we can all see that as well if I just do oc get cluster info, where my control plane's running. I'm just going to verify that my variable is set correctly, which it is. I'm now going to move into my CLife folder. So I've already pre-downloaded the manifests to install Isovalent Networking for Kubernetes into my environment. For any Isovalent customer today, you can get that from our enterprise documentation pages, and it also has documentation to take you through how to do all this in hosted control plane as well. So let's go into my folder. We've got a number of YAML files there that configure the CLife operator inside of the environment, and we've talked about that in our 1.17 release blog post about that new operator we have available as well. I'm just going to run a couple of commands which are going to inject those Kubernetes service host ports and addresses into my configurations. The first one I'm going to do that for is my CLife controller manager. Then I'm going to do it into the subscription. And then finally, we're going to add this into my Cilium config YAML as well. Now, the reason why I'm doing this across these three files is because I'm actually going to enable the kube-proxy replacement feature inside of Cilium so that I don't have to run kube-proxy on my cluster as well. So I'm going to just quickly check my Cilium config, basically using very default one that I've taken from the documentation itself. But ultimately at the bottom here, I've just added those extra two variables in. And then another file, which is really important, is the operator configuration for my cluster. So if you don't create this, then you may end up with the wrong settings inside of your cluster going forward when the CNI sets up. So the first thing we need to do is we need to code in that the default network is still type other, but also we need to set the kube-proxy deployment to false. And we do that by editing the custom resource for the operator. The kind is network, and the name for that is cluster. Again, all documented in our enterprise docs. So now we've got those couple of files ready and prepped. So I'm now going to apply the first manifests to my cluster. I'm going to apply the one that creates a Cilium namespace. That's where we install all the Cilium service itself with the right SAC and configurations inside of OpenShift. A little bit different to install into vanilla Kubernetes, where we typically just go into the kube system namespace by default. We're also going to install the custom resource definitions for Cilium as well, so that we can configure Cilium. So we'll apply those two. And then now those custom resource definitions are applied inside of that correct namespace as well. We can now apply the rest of our manifest inside of that file that will go into the right locations because the prerequisites are there. So now what I can just do is apply everything within my CLife folder. We'll get a couple of outputs for that, but nothing to worry about. So I'm going to clear that down. And now what I'm going to do is I'm just going to wait for Cilium to install and get up and running in the background as well. So I'm going to check that using the Cilium CLI command, and I'm just going to make sure that's supported the namespace of Cilium, and I'm just going to use the wait command in the background. So that didn't take too long to get Cilium up and running. I think probably maybe, 44 seconds that command was running for. So that was really, really fast. So yeah, we're pretty much done. We now have two clusters. So we've got our management cluster. We've now got our secondary cluster that we created, which should be now all up and running. So if we do OC get nodes, we can see one of the nodes has become ready. Two of the others are not ready at the moment. So again, we're just going to wait another couple of minutes for that to be up and running. Let's check on that node health now. So I've got those three nodes, they're showing us ready. Absolutely fantastic. We've got Cilium, we already know that's up and running. Status is healthy. And then if I do OC get pods all and just check the environment, we can pretty much see all the pods are now kicked in, started running. There's still a couple that'll be created in the background. So this is a higher number of pods now than we expected before. And because that CNI is now available, the rest of the OpenShift installation will kind of just finish off in the background. And that's where we're going to leave today's video of showing how to deploy hosted control plane inside of OpenShift using Cilium in that management cluster, but also in those additional clusters that are linked to it as well. Thank you very much.